Hi, I'm Sarah Raskin at Trinity College. My email address is there, and I'm going to be talking today about the use of a package that we've called the ReMIND package, which stands for Rehabilitation of Memory in People with Neurologic Disorders. This is specifically for prospective memory deficits, and I'll be talking about its use today in individuals with traumatic brain injury. So prospective memory is the ability to remember to do something in the future. It's been referred to as remembering to remember. It's probably not a unitary cognitive process. It involves encoding the thing that you want to remember, storing this intention, which always has to be while other tasks are going on, initiation of the intention, so remembering that you have to do something at the right time, executing the intention, evaluating the outcome, and then there's always a retrospective memory component, which is the thing that you had to remember. So we've all probably had the experience of knowing that you had to remember something, but not being able to hold on to the retrospective component. But prospective memory has, in general, been divided into time-based tasks, such as at 2 o'clock, you have to take your medication, versus event-based tasks, such as when the oven alarm goes off, you should take the food out of the oven. And as I said, prospective memory always involves an ongoing task. You're always doing something else in the interim before the time passes for you to execute the intention. Prospective memory errors can have serious consequences in daily life, especially around remembering to take medications, remembering to call loved ones or doctors or other healthcare providers, remembering to get tasks done for your work or school setting. And for a review of the kinds of ways that prospective memory is impacted by brain injury, there's a review that we did in a special issue of the Clinical Neuropsychologist in 2018. And that issue, by the way, includes reviews of other conditions as well. In terms of rehabilitation of prospective memory deficits, most of the studies that have shown significant improvement have used compensatory devices. So these can be phones or tablets or alarms or date books. NeuroPage obviously was very successful in Britain. Beth Twomley came up with CogSmart, which includes cognitive compensation strategies as well as some other strategies. There have been a few studies of prospective memory rehabilitation using restorative strategies, and a large number of studies also that have looked at metacognitive strategies. And the metacognitive strategies that seem to be successful include increasing awareness or sort of meta memory, visual imagery tasks, goal management training, and recently providing contextual cues. Implementation of intentions has been shown to be successful in other populations, but not yet in studies of people with traumatic brain injury. And again, for reviews of prospective memory rehabilitation, there's one by Fish, Wilson, and Manley, and then one that I wrote with McKay Solberg. Principles of prospective memory training include that there be sufficient trials, that there be sufficient attention on each trial, that there be reward engagement, and that there be a plan from the very beginning for generalization of treatment. And you can read more on this in a chapter by Brian Kolb. So I'm going to be talking today about one particular study. This is a randomized control trial looking at an individualized treatment program for prospective memory training. The primary outcome measure is the memory for intentions test, which I'll describe in a second. And then we also looked at generalization of treatment because, again, I think any rehabilitation study needs to really plan for measures of generalization from the outset of the study. We had 50 individuals with acquired brain injury and 25 healthy adults, all between the ages of 20 and 60. And you can see there the exclusion criteria. The demographic and clinical data are here. The ages were not different between the groups. nor were the years of education. You can see this months post-injury for the two injury groups, as well as the etiologies. The group here is the Cognitive Rehabilitation Training Group, or CRT, and the group here is the Active Control Condition, or ACC. And then these are healthy adults who did not have brain injury. In terms of measures of cognition, again, the primary measure is the Memory for Intentions test, which I'll describe in a little bit of detail in a minute. The other measures of memory were the Brief Visual Spatial Memory Test, or BVMT, and the Hopkins Verbal Learning Test, or HVLT. Measures of attention were the Brief Test of Attention and Digit Span from the WAIS. Assessment of executive functions were through a version of the Stroop, the Animal Naming Subtest of the BDAE, and Controlled Oral Word Association, FAS. Our measures of generalization went from very specific to more general. So our diary study, which we've used in previous research studies, looks at tasks that the person actually has to complete in the next week and how well they complete them, prospective memory tasks, that is. And again, I'll be describing that in a little bit of detail in a second as well. We looked at depression and anxiety. We looked at a comprehensive assessment of prospective memory, which is just a self-report measure of prospective memory. And then just looking at life in general, quality of life, we use the WHO quality of life brief version. So to describe the MIST for you a little bit, the Memory for Intentions test, or Memory for Intentions screening test, has two different time delays, 2 minutes or 15 minutes, two different cue types, time-based cues and event-based cues, two different response types, either a response that requires an action, often writing something down, or a response that's only verbal. And then again, an ongoing task, which in the case of the MIST is a word search task. So again, 2 minute or 15-minute time delay, event or type cue, action or verbal response, ongoing task is the word search. And then it also includes a 24-hour item where the person is asked to telephone a voicemail in 24 hours. There's a multiple choice recognition at the end, as well as a chance to do an error analysis, which we use in deciding what treatment to give. So to describe the diary study a little bit, which again has been published in a couple of our previous studies, these are 10 items that need to be performed in the upcoming week that the person actually does need to do. Pick up medications, buy socks, get milk, send a card to their mom, whatever it is. And it's scored on a scale of 0 to 2. 2 if it's completed entirely successfully. 1 if it's partially completed or completed at the wrong time, if it's late. And a 0 if it's not completed at all. For this particular treatment study, we did 6 one-hour training sessions within a 10-week period. We tried as much as we could to have the sessions be 1 to 2 times per week, but for some people with schedules, especially right now with everything that's going on, it was harder to get more regular training in. In this study, all of the trainings were done virtually via Zoom. Participants were randomly assigned to one of 2 conditions, cognitive rehab therapy or the attention control condition. The attention control condition was a program of education about brain injury. It was a series of PowerPoint slideshows with a little quiz after each module just to ensure that they were actually attending to the slides. And this was chosen because we wanted to be sure that their time wasn't just wasted doing something that wasn't useful or meaningful. And everybody who was randomized into the attention control condition was given the option of doing the active rehab afterwards. So we had a series of individual treatment modules, and we pick the module based on how the individual performs on the Memory for Intentions task. So if it appears from the Memory for Intentions task, like the primary deficit isn't paying attention, we might do attention process training, which is a package by McKay Solberg and Katie Mateer. We might increase the cognitive load slowly, that is, give them more things to remember at the same time. So in 10 minutes, do this, in 8 minutes, do this, in 5 minutes, do this, that they all have to remember at the same time. If the primary deficit seems to be encoding the cue, we might decrease the cue focality, which is how much the cue is related to the ongoing task. So start with it being very related and then slowly decrease it. Or we might decrease the cue intention relatedness. That is, how close is the cue related to the thing you have to do? So if I hand you an envelope and say that you need to put your address on it, those are pretty related cue and intention. But if I hand you an envelope and say you need to draw a cat, those are pretty unrelated. So start with a very highly related cue intention and then decrease it slowly. If the primary deficit is in retrieving the intention, we might do visualization training, which I'll explain in a second. Or we might do enactment, where we actually have the person act out doing the task when we give them the initial attention. So we'll say, in 10 minutes, I'd like you to turn the lights off. Could you please just get up now and turn the lights off so that we can see that you understand what you need to do? And then in 10 minutes, you'll have to do it. If the primary deficit seems to be in awareness, we would do goal management training. If the primary deficit seems to be time perception, they know exactly what they need to do, they just don't have a good sense of time passing, then we would do time perception training. And all of these modules are on our website, along with a manual for how to do each of them. And I'm just going to show you a few of them just to give you a feel. So for visual imagery, this was modeled in part after Grilli and Gliski. The individual is asked to imagine you are performing the task. Imagine with as much detail as possible. Please describe to me the details that you can imagine. And they're given feedback and suggestions to make their description more detailed. For goal management training, again, this is from the work of Brian Levine. Stop, what is my goal? Define the main task, list the steps. Do I know the steps? If yes, do it. If I don't, go back. And then for elaboration of retrieval cues, this is modeled after Addis, Wong, and Schachter. It's similar to the visual imagery condition, but in this case, the elaboration is focused on the cue itself. What will it be like when you see the cue or hear the cue? All of these were designed to take advantage of error-free learning, spaced retrieval, and sufficient repetition. And generalization of treatment, again, involved episodic future thinking training within the diary study, as well as the self-report measures in daily life. So looking at the results on the measures of memory in terms of the MIST. So this first bar is people that received cognitive remediation pre-treatment score, and the orange bar is post-treatment score. This kind of olive green is the attention control group pre-treatment. The brown is attention control post-treatment, and the purple bar in the middle is the healthy adults. So I can see here is on the MIST, the only significant difference was an improvement in the cognitive rehabilitation group. On the BVMT, the same is true. And on the HVLT, there were no significant changes in either group. In terms of attention and executive functioning, we found significant differences on the Stroop in the color word condition for the CRT group versus healthy adults, and for the attention control group versus healthy adults. In terms of measures of mood, both groups showed significantly elevated levels of depression and anxiety compared to the healthy adults, but there were no significant differences from pre to post treatment in either group. In our measures of generalization, again, so what you can see here is there was a very large significant increase on the diary. In the cognitive rehabilitation group, there was no change in the diary in the attention control group. Both groups pre-treatment were significantly impaired compared to the healthy adult group. There were no differences in terms of the self-report prospective memory measure or the quality of life measure. So to summarize, Pre-treatment individuals with brain injury were impaired on total MIST scores and PM errors on the MIST. Individuals with brain injury demonstrated significant decreases in BVMT total recall and learning scales compared to the healthy group, and the individuals with brain injury demonstrated significantly lower scores on the Stroop. In terms of pre-treatment to post-treatment changes, the cognitive rehabilitation treatment group showed significant improvements on the MIST, the BVMT, and the diary study. The attention control group did not show any significant changes. So individuals with traumatic brain injury improved on the training task of prospective memory, and treatment gains were reflected in measures of generalization. In terms of future directions, I think it's very important that we begin to look at cultural and language factors, both in the assessment and in the rehabilitation of prospective memory. And there's been some work done already looking at assessment in a paper that we published in 2019, a book chapter, and a recent paper that came out by Turison along with Monica Rivera-Mind. We may need to look at a more fine-grained analysis of prospective memory failures. We're looking just at the error analysis from the MIST, but we might need to look at that in more detail to individualize treatment better. We might need to look at different methods for each of these techniques. So for example, for visual imagery, does it matter if it's self-imagery versus observer imagery in terms of point of view? May need to look at some underlying mechanisms like arousal, and especially motivation is something that people have looked a lot at in terms of prospective memory in general, and that probably will have an impact on memory rehabilitation techniques. And I'll show you a couple of slides, some early work that we've started to do looking at imaging techniques to look at changes in brain activity following treatment. So this is data that we've been collecting with Michael Stevens at the Olin Neuropsychiatric Research Center. What I'm showing you is an N of 4 individuals from the previous study that I just described to you. And this is showing you visual representation of where there was activation for the individuals with brain injury for the prospective memory task, which is a separate computerized task within the magnet, looking at ongoing task versus prospective memory task. And so in sum, what this showed was there was evidence of activation in BA10, which is the region that's been previously implicated in prospective memory tasks, and a significant presence of activation in other nearby orbitofrontal complex regions. Other future directions is that we might need to tailor treatment based on severity of injury or severity of deficits, which obviously are not the same thing. There have been one recent study in 2020 of teletherapy with prospective memory in general. And I think coming out of this pandemic, we may be looking at ways that we can continue to deliver prospective memory treatment virtually for those who have impediments to coming into in-person treatment. And we might want to look in more detail at using episodic future thought as a measure of efficacy, but also perhaps as a new module. For example, Alicia Kamui in my lab has created a standardized measure of episodic future thought called the Pre- and Reimagining Mental Events Task, or PRIME. And of course, we need to be always thinking about how this generalizes to everyday life in a way that is actually helpful and functional. And so thank you very much. I'm happy to have questions emailed to me or sent to me in any form. I'd like to thank funders and also the students who are currently in my lab.